A very good morning to one and all. Respected principal, distinguished guests, esteemed faculty members, resource persons, participants, and dear students. It is my privilege and pleasure to welcome you all to today's program. On behalf of the Department of Computer Science and Engineering, Adi Shankara Institute of Engineering and Technology, it gives me immense pleasure to welcome you all to the inauguration of the 6-day online NBA GAP-C V4.0 aligned Faculty Enablement Program on Industry Practices in Software Development for Complex Interdisciplinary Challenges, organized in association with Tata Consultancy Services. The program is scheduled from 15th June 2026 to 20th June 2026 from 10:30 a.m. to 12:30 p.m. and aims to bridge the gap between academic learning and industry practices in modern software engineering. Let us begin this auspicious occasion by invoking the blessings of the Almighty. I invite C.R. Krishna from the final year CSE to lead us in prayer.
Tanavavatu Sahano Bhunaktu Sahaviryam Karavavahai Tejasvinavaditamastu ma vidvishavahai Shanti, Shanti, Shanti.
Thank you for the prayerful beginning, Krishna. Every meaningful gathering begins with a warm welcome, setting the tone for the sessions ahead. The successful organization of this faculty enablement program reflects the dedicated efforts and leadership of our head of the department, who has been instrumental in bringing together this initiative. With great pleasure, I invite Dr. Ramani Bai V, Professor and Head, Department of Computer Science and Engineering, ASIET, to deliver the welcome address. Ma'am, please.
Thanks, Parvati. Namaskaram to all. The NBA aligned faculty enablement program on industrial practices for software development for complex interdisciplinary problems. It's a thought process during a session that during our Dr. Jana sir, during the development program, NITTR, happened in our institution. That taking the complex engineering problem and mapping to the sustainable development goals. So that provoked, so we have to go for a specific to this aspect as the faculty enablement program on this specific aspect. So with this note, we welcome all of you who have gathered and who are going to participate this a 6 days enriching faculty enablement program organized by Computer Science Department at Adi Shankara College of Engineering, Kaladi, Kerala. So when I approach our principal, sir, so this is what we want to do. Shall we go for it? Then immediately he said, yes, madam, you can go. So this is what the institutional encouragement and support that we receive for all our initiative and the endeavors that we take upon for the growth of the students, faculty member, and the institution. In his absence here, I shall welcome our esteemed principal, Dr. M.S. Murali, to this program. Then, as I introduced our beloved Dr. Janardhan sir, this is the basis of this inauguration, no, this FEP, and we are blessed with having his presence in this occasion. So, having the clear conceptual understanding of complex engineering problem, especially to the software development, we need to have the blend of industrial practices. Then immediately, TCS came to my mind. And we have Mr. Rajiv Srinivasan, the Academic Alliance Head, TCS Kochi. He is there for all our support and help whenever we extend our hand for help. He extends his hand for supporting us. And immediately he said yes, and we carefully structured the contents of all the 6 days, and we shared with him, and immediately he approached the internal resource persons and delegated those resource persons. And we have shared the brochures, details, everything with all the participants who have joined with us now. And with this note, I shall welcome Dr. Jacob Thomas, the Delivery Manager of TCS, who is going to inaugurate this session. And we are indebted and grateful to TCS for extending their valuable time, effort, and their presence for bridging in the academia and industry gap for the benefit of the the aspiring engineers. So welcome you, sir, to this program. And we have our Dean Research, Dr. Sripriya S. And she's instrumental for conducting the FEP on NBA through NITTR. And she plays a vital role in enhancing the academic quality and encouraging the faculty and students indulging in the deep research, so that the overall quality of the institution and the outcome can be reached as per the expectation. Aditya Group, it is only 10 rupees registration. I just wanted to know what is that and what they can offer at the for the cost of 10 rupees. When I discussed with my son, he said, no, don't go for it. No, it will be a scam. Don't go for it. But still, I was really curious. I want to attend what it could be that, because I do not have any, even if it is a scam, something to hack, I do not have any secrets or nothing, much in store in the bank. So, okay, let me take a risk of attending it. So they have exposed some 10 AI tools. That was an introductory session for the pool of certification programs they are offering through their startup BE 10X. But through that workshop, and at that point, I realized AI tools are the advanced tools are going to help us. So that's going to save us. When we say tools, in automation, we call that as a software. A team of software developers spend the whole time time and energy building the software and offering that as a tool to the community or the public, which we can use for our benefit. And interestingly, the AI tools come to a point wherein a software can develop another software. So what could be the complexity of the base product that they might have taken it? So that gave me quite a lot of understanding. So how we shall go about it? I see this is a modernized kitchen. Janardhan sir will be happy with this example. So we have all the advanced gadgets in the modernized kitchen. So that would save all of our time and the manual effort in making the food, preparing the food. But that will not ensure the quality of the food that we prepare. That is not going to nourish us. The problem that we have is how we are going to prepare the food with the help of the modernized gadgets that we have in a modern kitchen. And this kitchen is going to serve the public. So considering the advisory conditions of the complex nature of the public, it is going to serve it. So let us nurture us with the quite a lot of input over the coming 6 years, sorry, 6 days, through the renowned, suitably approached resource persons for this FEP. They are really open to share their expertise with us, and let us nourish ourselves and enable the aspiring engineering graduates ready for industry needs and the social needs. Thank you all. Welcome once again to this FEP.
Thank you very much, ma'am, for the warm and heartfelt welcome address. One of the key objectives of this faculty enablement program is to bring academic perspectives closer to current industry practices. Our chief guest has been at the forefront of fostering meaningful collaborations between academia and industry, helping educators and students align with evolving technological demands. It is my privilege to invite Mr. Jacob Thomas, Delivery Manager, Tata Consultancy Services, Kochi, to deliver the inaugural address. Sir, please.
Thank you so much. Am I audible?
Yes, sir, you're audible, sir.
Yeah, okay. Thank you. Thank you so much. So thank you, Parvati, and respected Ramani Madam and Dr. Janardhanan Sir from the NBA. It's indeed a pleasure to be here, being associated with Adi Shankara and the FEP that it has scheduled for 6 days. Being part of TCS and TCS being joining hands with Adi Shankara for this FEP is indeed an opportunity that we see where we can nourish the faculties through this FEP, and the faculties will be indeed be able to go and train the students. So this train the trainer program is what TCS usually does, and we are indeed committed to the society for upbringing and making sure that the industry academia bridge, which Ramani ma'am was talking about. So this bridge has to be as much small as possible, so that once the students pass out from the college, they can directly join us in the organization or the industry as a whole. And these are all very changing times. If you ask me, there is a lot of technological enhancement that is happening. But whereas when it comes to technological enhancement, it's not necessary that all the technology that comes into market is adding value to the business. So that is something that we tend to overlook, because the business comes first and technology is an enabler of business. However, for companies like us, where technology itself is the business of us, we tend to push and we tend to make sure that the customer gets or sees the value. And once they sees the value, they adapt to it and they accommodate this particular technology into their realm. And that is how business transformation will happen. So in this particular workshop or scenario, where in the 6 days you will come across different complex problems, you will come across what is business transformation, how the revenue models are being transformed, how business models are being disrupted by different problems. And now disruption is nothing new. If you ask me, disruption has been happening throughout, and it's in one form or the other. And many technologies, like if you ask me, blockchain is the first thing that comes into my mind, wherein it was also called a disruptor. However, if you notice now, it has not had its run in the time. But however, there are, AI is now being spoken about. Ramani ma'am was speaking about AI, and we are now in a scenario where there is a lot of hype in the market, where they are telling that okay, enterprise will come after it, industry will go after it, and all of us need to know about AI. It's definitely there. We all need to know about AI, but the value that AI brings to the table or the value that AI brings to the existing business model is what we should definitely look into. Because ultimately, in the example of kitchen, what we need to understand is in whatever tools that we use is ultimately to prepare a dish, and this dish is, if not tasty, if not having the nourishment value or the calorific value, or it has certain percentage of protein, it has certain percentage. So if that is not in place, then whatever tools you use to cook it will not be fruitful. And ultimately, that is what matters. That's what the end user wants. If the child is hungry at the table, and despite the mom is trying different things out in the kitchen to cook the dishes, that doesn't matter. Ultimately, the hunger of the child has to be quenched. So that is what the business objective is, or the customer satisfaction is. Because the customer, to the child who is sitting at the table, whatever they try to, even if you use an air fryer or oil fry it, they are just looking at, first is the minimum thing of hunger being quenched, second is the taste, and third is then comes the whether it's apt salt or not. So there is three levels to it. So in the initial, business should run, that's my hunger should be quenched, and second is my experience should be good, the food should be hot, the food shouldn't be that cold. So, and then comes the third part where I can judge whether there is sufficient salt or not. So this, only once this three things is measured, then the fourth thing that we look at is how was this prepared, and that is the thing. But ultimately, for academicians in the computer science area or industrial people like us, we always look at how it is being cooked, and we look at we focus on the process, forgetting that what the value or the end users are looking at. So that is something that we will definitely look at, where this is a paradigm shift of seeing what the end user sees as value. Right. So I wish you all the best. I understand that there is a lot of faculty who, I see close to 95 people who have come here to attend this FEP. I wish you all the best. And this program will definitely add value to your teaching momentum. And once you are aware of what the technology can do, and what the end users of technology will receive, you will definitely chart a path in which your students can also learn it. That is definitely my belief. So thanks again, once again, thanks again, Dr. Ramani Madam, for having TCS partner with this program. And thanks again, Dr. Janardhan sir, for this particular opportunity, for having connected with Adi Shankara and as TCS. Thanks again for coming and giving us this session. I declare this, I inaugurate this session. Thank you so much, ma'am. And back to you, Parvati, madam.
Yes. Thank you, Jacob, sir. And I know there is an adjustment between Mr. Rajiv and Jacob, sir, for no, for this session. And thank you for immediately attending us. And I apologize for missing out our CTO, Professor Rajaraman, who's heading the AI research at Adi Shankara Institute. And he's in the hospital taking his mother for a treatment.
Ma'am,
for a
ma'am, I've
dental
joined.
crisis. Yes, sir. Yes, sir. So
Yes,
I
ma'am.
missed out, sir. I just noticed it.
No,
And this is
I
the
just
level of
joined.
commitment he has, to serve our request. So I shall wholeheartedly welcome you to this program, sir.
Thanks a lot, ma'am. It is indeed my pleasure.
Yes, please proceed, Parvati.
Thank you, ma'am. And thank you, Mr. Jacob, for your words of encouragement. Research and innovation are essential pillars of academic growth and professional excellence. Through her continuous efforts in promoting a vibrant research culture, our Dean Research has inspired both faculty and students to pursue innovation and scholarly achievement. I respectfully invite Dr. Sri Priya.
Thank you, Parvati, for the kind words. Namaste to all. Respected Principal Dr. M.S. Murali Sir, our esteemed Chief Guest from TCS Kochi, Mr. Jacob Thomas, and other resource persons, Dr. G. Janardhanan Sir from NITTR Chennai, and Dr. Nimal Krishna, Mr. Joby Joseph, Mr. Vinod Venugopal from TCS, dear faculty members of Computer Science Department, and dear participants, a very good morning to all of you. As we inaugurate this 6-day FEP, I must congratulate Department of Computer Science and Engineering for choosing such a theme that is incredibly timely and vital. As Remini ma'am and Jacob sir was pointing out, today boundaries between the traditional engineering disciplines have completely dissolved. Whether it be robotics, whether it be healthcare, automation, smart infrastructure. See, most of the groundbreaking innovations are happening at the intersection of different fields. And at the heart of solving all these complex multidisciplinary issues, I would say the heart is robust software development. So I think this particular FEP is very much vital.
I think her call is being dropped. Shall we wait for a moment? She has
Yes,
dropped.
madam.
Ma'am, Shridya ma'am, you're on mute, ma'am. Can you unmute yourself, please?
Please.
Yes, ma'am, you're audible.
Sorry for the interruption. Sorry for the interruption. Okay, so this particular FEP is very vital and timely. And as faculty and as researchers, our responsibility would be to fill in the knowledge sharing in the classroom along with the dynamic industry realities. So this FEP will be a phenomenal opportunity for all the participants to upgrade our toolkits and absorb the best practices, especially from industry giants like TCS. So I hope that this will bring that high impact knowledge to our classrooms and our research activities. So I urge all the faculty participants to completely utilize all the fruitfully utilize all the sessions in the 6 days, discuss, deliberate, and learn from the giants, industry giants. So let this program not only bring a learning experience, but let it act as a catalyst for interdisciplinary researches and innovations which is happening in our institution. So I would like to wish all the organizing team and all the participants of this program a highly productive 6 days. And I once again congratulate the team for organizing such a FEP and express my heartfelt gratitude to all the resource persons from TCS and Dr. Janardhan sir from NITTR. And I wish all success. Thank you and Jai Hind.
Ma'am, for your words of encouragement and for your kind support. As technology continues to transform every sphere of society, the importance of industry-oriented learning becomes increasingly evident. Our next speaker has been instrumental in strengthening technological initiatives and fostering innovation-driven learning within the institution. Sir, please.
Parvati ji, am I audible?
Yes, sir, you're audible,
Okay.
sir.
Okay. Thank you. Respected Principal Dr. M.S. Murali, Professor and Head Dr. Ramani Bhai V, our distinguished guest Mr. Rajiv Srinivas, Region Head Kerala Academic Alliance Group, TCS Kochi, Dean Research Dr. Shipriya S, faculty colleagues, and my dear participants. Good morning to all. It is a moment of great pride and privilege to be present before you as we inaugurate this 6-day online FEP on industry practices in software development for complex interdisciplinary challenges. In today's rapidly evolving technology landscape, the bridge between academic learning and industry practice has never been more critical or crucial. Especially software development today is no longer confined to writing code. It encompasses something like agile methodologies, DevOps pipelines, native cloud solutions, AI-driven automation, and whatnot. And as its heart, engineers are expected to navigate complex interdisciplinary ecosystems. For example, our product may start touching healthcare, finance, logistics, and maybe all at once. So at this juncture, this FEP that is also aligned with the NBA V4.0 is a step exactly in that direction, equipping or enabling our faculty and students with real world perspectives that transforms good engineers into great problem solvers. In fact, in all our academic council meetings among HODs, we've been trying to target this particular problem of how to transform engineers into great problem solvers. And I'm particularly delighted that TCS, one of India's most respected technology institutions, is our partner in this endeavor. And their presence here is not just support, but it's validation of Adi Shankara's commitments to excellence. So as we begin this journey over the next 6 days, I urge every participant to engage deeply, ask questions boldly, and carry these learnings into your classrooms and your projects. Thanks a lot for this opportunity. Jai Hind.
Thank you, sir, for your kind and inspiring words. Successful event for the plan, teamwork, and innovation.
വേറെ സമ്മതിക്കാറ് പറ്റുക ഗേൾ ഫ്രണ്ട് വിളിച്ചോണ്ടിരിക്കുക
Faculty enablement program incorporates system and effort. To formally stress our gratitude all responsible to this occasion, I invite Dr. B. Coordinator CP to propose.
Am I audible?
Ma'am, please.
Okay. Good morning, all. It is my pleasant duty to propose a vote of thanks on this auspicious occasion of the inaugural session of our 6 days online faculty enablement program on industry practices in software development for complex interdisciplinary challenges. Today, we are deeply honored by the presence of Mr. Jacob Thomas, Delivery Manager TCS, who graciously inaugurated this program. We thank him for sharing his valuable insights on industry expectations, emerging technologies, and the importance of strengthening academia industry collaboration. His inspiring address has set the perfect tone for the program. Thank you, sir. I would like to extend my heartfelt thanks to Dr. M.S. Murali, Principal ASIT, in his absentia for his continuous encouragement and support. Thank you, sir. I would also like to express my sincere gratitude to Dr. Sri Priya S., Dean Research, ASIT, for her felicitation and motivating words, which have encouraged us to pursue excellence in teaching, research, and innovation. Thank you, ma'am. Our heartfelt thanks to Mr. P.V. Rajaraman, Chief Technology Officer, ASIT, for his valuable felicitation and for highlighting the significance of continuous learning and industry-oriented skill development. Thank you, sir. I express my sincere gratitude to Dr. Ramani Bai V, Professor and Head, Department of Computer Science and Engineering, ASIT, for extending a warm welcome to all the dignitaries resource persons, and participants. Her efforts in organizing this program and fostering academic excellence are truly appreciated. Thank you, ma'am. I would like to thank Ms. Ambili Mohan, the coordinator of FEP, for her dedication and hard work. Thank you, ma'am. I also express my sincere gratitude to the subcoordinators of the FEP, Mr. Anjush RK and Ms. Hida Roki. Thank you. I take this opportunity to thank the management of Adishankara Institute of Engineering and Technology for providing all the necessary support and encouragement for organizing this program. I also extend my appreciation to all the participants who have joined us with enthusiasm and commitment to enrich their knowledge and professional competencies through this faculty enrichment program. Finally, I thank the organizing committee, faculty coordinators, and technical support team whose dedicated efforts have ensured the successful conduct of this inaugural session. With these words, once again, I thank all our distinguished guests, resource persons, and participants for gracing this occasion with your presence. Thank you all.
The paper.
All the participants, please turn on your camera so that we can take a snapshot of this. So could you please, or could all of you please turn on your camera?
Thank you, participants. Before we begin the session, gentle reminder to the participants to kindly adhere to a few guidelines. We request you to keep your devices on and at the end of the 6 days, a test will be conducted for 30 minutes. It is mandatory to score 75% marks to get the certificate. Thank you. Now we will begin with the first session. A warm welcome to the first day of the 6-day online NBA GAP CV 4.0 aligned faculty enablement program on industry practices in software development for complex interdisciplinary challenges, organized by the Department of Computer Science and Engineering at Adi Shankara Institute of Engineering and Technology. To introduce our resource person for the first day session, Dr. G. Janardhanan from NITTR Chennai. Dr. Janardhanan is a distinguished academician and expert in outcome-based education, accreditation, and quality enhancement in engineering education. He has guided numerous institutions in implementing NBA guidelines and aligning academic practices with accreditation requirements. His vast experience in engineering education reform and curriculum development makes him an ideal expert to lead today's session. The topic for today's session is NBA GAP-C V4.0, Identification and Analysis of Complex Engineering Problems. Sir, we are really delighted to have you with us. I kindly request you to take over the session. Over to you, sir. Thank you.
Janardhan sir, I shall apologize. I asked only 15 minutes of your time for inaugurating, but you have taken almost 45 minutes. I wish and I request all the participants to stay back until the completion of the session. And you really enjoy session. Sorry, sir. Please start your session, sir.
Now, madam can show feel the difference between the online session and the offline session. Because
Yes,
sometimes I prefer the offline session in a different manner, but online session is also important nowadays but I have seen some centers when we offer online, we make a mandatory of we make online session very, very important. The reason is where the participants, we can cover in a different perspective. But today the topic is on complex engineering problem. Madam is well about the complex engineering problem and connected to GAP-C 4.0. GAP-C 4.0, and as you all aware, the Government of India, National Board of Accreditation, has introduced or launched GAP-C 4.0. What do you mean by GAP-C 4.0? It is Graduate Attributes and Professional Competency 4.0. As long these many years we were discussing about graduate attributes, we presumed the professional competency will come back by default based on our robot assessment pattern. But later on, it has been observed the professional competency does not reflect the degree what they obtain. There is some gap. That might be the reason of GAP-C, the word. That it is GAP-C is graduate attribute into gap there. For example, why this gap exists? Because in developed country and developing country, how the things have been taken in a different perspective. To put a small analogy before the starting of the session, recently I was being assigned to an auditing work in by the one of the government agency in one state. I went to Western state. We have to travel from the airport to that place. Generally, it takes 3 to 4 hours. We will be traveling, but that day took 7 hours for us to travel because of the one fault by the driver in one place, not our driver, some place. The entire traffic has been stuck in the GOT road. It was a unique. Because of this mistake, this issue has happened. And it is, he does not know how to drive. That was the things which the people are telling and everything. So then we correlated this thing with our assessment pattern. Previously, when the people possess the driving license, we presume they know how to drive the vehicle, either two-wheeler or four-wheeler. Very fantastically, they were driving, and the driving license also certifies the same. But because our driver was mentioning, these guys are getting drive license, sir, but they don't know how to drive in the road, sir. That was the argument he was making in the car with us. This was statement he was making. So then I recollected. In India, when we go for a driving license, either two-wheeler or four-wheeler, whatever be the number of people who will be standing in the queue will be enormous always. And they have to stand outside in the hot sun, everything. It was a different experience which we will have. Obviously, everyone would have faced this experience. And the people might have treated in a different perspective also. So in that situation, how to handle, it is difficult. But the same when I went to US, there also the driving license was this thing. As Indians, we might be getting a driving license here, but getting a driving license in US is not a tough job. it is a really good job. They have a very systematic procedure. In the car, I have observed here 4-5 people will, 3 people will be sitting in the same car. Each one will be driving some part and everyone will be getting a license. But in the US, 1:1, one driver and one people, they will be taking an entire stitch for more than 45 minutes, 50 minutes, uphill, downhill parking, how to give the reverse, when the two cars are there, inside, how we have to park, everything. Fantastically, they make the driving license. But if the person possesses the driving license, by default, he knows how to drive and without any problem. But here, what happened? Here we will be possessing the driving license, but the competency what we obtained, sometimes it matches, sometimes it mismatches. We are not making a critique of any system. We are only dissecting or critically looking into the things, introspecting, so that we have to get enlightenment. To similar manner, for the past several years, from 2014, from GAPC 3.2 onwards, the accreditation agencies were focusing for undergraduate on complex engineering problem. The complex engineering problem was not a new term to be introduced. It was already there. Already, if you see the POs of your institution which are listed from 1 to 4, the PO complex 1 to 5 PO, the complex engineering word will be there. Now, in GAPC 4.0, they introduced the graduate PO number 6. That is the only condition they have introduced. But what exactly we mean by the complex engineering problem? Why we need to dwell upon the complex engineering problem? Or only the complex engineering problem we have to work? The main issue is we don't know the difference between the well-defined problem, broadly defined problem, and complex engineering problems. Suppose most of the places know we are doing skill gap. But skill gap is entirely different. So I have associated with some CSTS, Construction Skill Training Institutes of the country, where we have associated, where they will be taking a school dropouts and they will be teaching you some skill which will empower them to be a worker class. Because where you should know the difference between ITI, below ITI, polytechnic, engineering, and technology. This is the way we should know the difference. But unfortunately, we are mixing everything and we are getting into the confusion state. So today's lecture is going to focus on what exactly you mean by complex engineering problem, how to define the complex engineering problem. This is the part 1 of Drishyam 1 today. Tomorrow in Drishyam 2, we are going to connect to SCG. That's what the timing they have given. Today one session, tomorrow one session, I think. So that's the way we are going to take it and we are going to operate up accordingly. And because as Madam knows, today we came to the NIT Calicut. We are conducting one program on strategic planning and institutional development. I was not listed, but unfortunately, our administration and Suresh sir made me to come to NIT Calicut. But it's a good place. I enjoy and cherish this place. So today we are going to discuss about various aspects of complex engineering problem and complex engineering aspects. Let us focus one by one, which will give a clear insight about the different aspects of the this thing. So let me share the PPT. Now, our Ramanibai madam should come up with the framework what need to be incorporated in online learning and offline learning to make the difference of the sessions. Because sometimes the same session, when we conducted in offline, it will be of a different genre. When we conduct in online, it will be of a different genre. So let me share the screen. I hope my screen is shared.
Yes, sir. Your screen is being shared properly, sir.
Okay. So So in accreditation gap C 4.2, the complex problem solving or complex engineering problem we are going to discuss. So as usual, in this lecture, content expressed are purely my technical perspective. It does not represent the organization with which I am affiliated. So you might have observed as a faculty members, I hope everyone are faculty members, you might have observed the word complex engineering problem already. It was not something new. After 2014 itself, we one-to-one and one-to-many concept was there before 2014. After 2014, one-to-one concept we are going. So what you feel or what you visualize by the term complex engineering problem. Let us be frank, because the ultimate next 1 hour, 60 to 90 minutes, which we are going to invest, my duty or my responsibility is to provide clarity of what exactly the word mean by complex engineering problem. And it is my dharmic responsibility, and I should make it clear. And sometimes we might get clarity or you might get confused. If you get confused, that is also a good clarity because you are getting confused and going to the right path. So let me take from the participants. You can put it in the chat box. What exactly you mean by the term complex engineering? Whatever comes to your mind, you just put it. I just want to know the perceptions or the view of the participants before starting the session. What exactly you mean by complex engineering problem? What is your view? I hope everyone is having access to chat. Oh, continuous chat is turned off. Okay. No chat messages. I don't know, maybe continuous chat is turned off. Maybe I don't know. Only chat is turned off here, but between the WhatsApp messages you can share. Okay, the message is turned off, I think. If not, I don't know. Message is turned off. What is your view? Anyone can? Yes, complex engineering problem is Vaishaka Krishnan sir is engineering challenge that requires advanced knowledge, critical analysis, consideration of multiple constraints, and possible solution to solve effectively. Problem cannot be solved by the formula. Rajiv Vinod, madam. Correct, perfect. Vaishak Krishnan. Hello, sir. In-depth engineering problem. Parvati Nair, madam. Last time she attended. So, in-depth engineering type knowledge. Okay. Vijayalakshmi, which takes more resources and time. Is it so? Maybe, I don't know. Maybe we have to decide. Which takes more resources and time. But as experts, sometimes complex problem could be solved in a short time also. Okay, it's a good perspective. Okay, engineering problem. Vaishak Krishnan has given a very big message. Okay, also solving problems by using multidisciplinary approach. Okay, fantastic. So much resources and calculations needed. Okay. So much resources and calculation needed. Fantastic. Okay. Okay, fantastic. So everyone, overall, not possible for humans to solve. Advanced, sir. Okay, not for, but you are only going to solve Vijayalakshmi, madam. Then now, then we become alien or we become Devatas. Okay, maybe okay. Advanced or new problem. Gopi Kannan sir is telling advanced or new problem. Okay, fantastic. Each one have told their own reflection, interaction of several systems and knowledge. Perfect, 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 perfect. Okay, so we have our own notion. Complex means always complex, complex. And we wonder in engineering, there is no simple problem why everything has to be complex. Our teaching is complex, evaluation is complex, life itself is complex. So what is it? Okay, let me focus one by one. and engineering, whether it's lost its charm, we don't know. Maybe the way in which we orchestrated may resulted in the losing is the charm of the engineering. Because even if it's civil engineering or computer science, any engineers, the people are very good in conceptual knowledge. But when it comes to implementation, there is some gap is there. That this complex engineering problem or professional competency wish to minimize that gap. Minimize the gap so that the gap is minimized. The people will be having a clarity. That is one objective. So we want to minimize the gap between the industry and the academia. So to bridge that gap, we should learn from the perspective of the industry, because last week I went to the NSGs, National Security Guard, for some meeting where we went. So how the constructions, the bullet, how it has been operated. Even a senior people from they had a different perspective of NSGs, the construction. So all constructions are not unique. No, it is same. It has to be different. But that is the reason now to make a Viksit Bharat. It is not the academia need to be strengthened. It is academia should focus on connecting with the industry. When connecting with the industry, predominantly we adopt one of the best formulas, signing an MOU. We sign an MOU, we make a MOU, and then we offer programs. That's it. But how to work as a software engineers? When our team was working on developing some softwares or making a gateway, developing a web page might be easy, but connecting to it, how to minimize the data usage collection, how the entries has to be minimized, how the security need to be checked. As a youngsters, they are not aware of all those things. Each branch has its own problem. But teaching, learning process, past, present, future, if it is there in the same direction, it's going to be a problem. Past and present, it is the same direction, but future, there has to be relook the way in which we orchestrating the classroom instruction. It is not just the content delivery, it is connecting the content to the context. When you want to connect the content to the context, then the students can visualize how the problem could be categorized into simple or complex. It is a difference between well-defined problem, broadly defined problem, and complex defined problem. But predominantly in the undergraduate education, we are focusing on well-defined problems or broadly defined problems, but our focus is not with respect to complex defined problems. So we cannot continue the past and present for the future because the future is highly AI oriented. Everything it comes, whether it comes authenticated, we don't know, because the assessment pattern should not focus on routine content. It has to focus on a different perspective. Today morning, when we are discussing with NIT, we were discussing about new model infrastructure. Infrastructure as is important. The infrastructure is also as important. Infrastructure building is important, but the information or digital structure is also important. Not only it is important, it becomes a culture for it. Info culture is also important. So in the session, I am going to discuss what constitutes a complex engineering problem. What makes a problem into complex? Whether teaching of mind makes it to complex or explanation of mind make it to simple. That's a good definition which we are going to discuss. Second, what is the difference between a routine problem and a complex problem? How to incorporate this aspect into the final year project, mini project, micro project, or a capstone project in collaboration with the industry. It is one part is connecting with the industry, second part is connecting with the SDGs. So one of your faculty member also has asked the doubt, but continuously I was traveling every day. I was coming late evening and late night to the visit. After last week, completely I was in visit to different. Even though I was in headquarters, I was every day traveling at morning 7 o'clock. I used to leave and come back by 8 o'clock to the campus. After coming to the campus at 8, work was there for 40-50 minutes. Then going home, it was 10. That was the issue last week. So that is the reason I didn't reply his mail also. But we are going to discuss between routine problem and complex problem. What are the ways which you can analyze? The complex engineering problem means 7 attributes are there. That 7 attributes we need to aware what exactly the 7 attributes are there. What all the attributes contribute to the complex engineering problem? Use of engineering tools, because the complex engineering problem, it is not simple with the first year subjects. It is with some software tools also. You need to be in the position to understand what you mean by corrective action, root cause analysis. All those items we are going to have. And then finally, we are connecting to the graduate attributes WA1 to WA4. But this is a photo which I've screened in most of the training programs. If you observe, when I go to the class, I want to expose to the new ideas, want to experiment with my understanding of these ideas. If something is confusing, I want to able to ask questions. If something is mind-blowing, I want to talk about it a lot. I want to know it means the same to others. I want to have a deep insight that matter to me. I want to be excited, inspired, and encouraged. I want to be seen. I want to be able to use what I learn and share it with my world. This is the statement. But when it comes, I don't like the exams. But how I need to test it? This complex engineering problem cannot be tested by the written examination. It has to be tested basically with the projects or activities where they have to work and they have to prepare the report. But it is not by-hearted report. It has to be visually presented in a different manner. So if you see the engineering landscape, as I told you at the beginning of my lecture, the way in which we get license. So number of people were less. So assessment were very active. So the people whoever obtained the license, they are performing very well. Now number of users become more. The assessors are the same number. So there is a flaw in the assessment pattern, which resulted into definition. Whoever hold the license doesn't need to know how to drive it. That is also becomes a problem. So the landscape, how it has changed. Real world engineering is not a textbook based problem. Obviously, it is not textbook based problem. Only when you work in the field, we know the reality or nuances. So how we have to work? Because sometimes when we interact with the common people, they provide a very simple solution for a traffic problems. But we make complicated as engineers. Sometimes we ourselves only are complicating. So the stakeholders involvement is very, very important, which is also one of the attribute in the complex engineering problem. Real world problem. Textbook problems generally provide well-defined problems. One correct answer with a given data. So these are all well-defined problems or broadly defined problems. Well-defined problem or broadly defined problem. But industry presents ill-defined, multifaceted change challenges. Multi-faceted challenges. For example, one of the faculty member or a participant has listed, it should be multidisciplinary or interdisciplinary, 100%. Most of the softwares which are related to any of the engineering domain, it is not developed by the discipline people, it is developed by other people. Then I should understand the grip of what exactly I need to know. So that becomes a big problem. So industry represents ill-defined or well-defined challenges. Well-defined or ill-defined or well-defined challenges. That is a problem. Then comes the ability to analyze and immediately jumping to the solution is not the one how we have to do. Because Einstein has clearly told, if I have been given 1 hour to save the planet, I would spend 59 minutes in defining the problem and 1 minute in solving the problem. So in complex engineering problem, it is not the time that matters, not the resources that matters, how much time you dwell in dissecting the problem that matters a lot. If you know how to define the problem or how to look into the problem, how to synthesize the solution based on the analysis what we do, the complex engineering problem becomes simple. But dividing the complex engineering problem to simple, we need to know what exactly the complex. So let us focus on it, what exactly the complex agenda. So a complex engineering problem as a characteristics. As I told you, engineer means if you declare someone as an engineer, he has completed a graduation of 4-year BTech degree, then these are the attributes which you should process. Suppose if it is Puttu Kadalakari means Kadalakari should have some attributes. What Kadalakari should have? Kadalakari should have Kadala first. That is very, very important. So what Kadala? Black Chana or white Chana? If it is white Kabuli Chana, it is different. Generally, I have seen black Chana only they are giving. Or sometimes Puttu are also given with green gram. I have seen in some hotels they give with green gram with papad, everything they are giving. So it is just to be defined. It has some characteristics. Puttu means it has some characteristics. It made from rice, it is from white rice or red rice, it is there. So each, when you declare something, it should have some characteristics. If you declare a person as an engineer, they have a graduate, engineer graduate, means they possess some attributes. They possess 11 attributes. These are the attributes which defines a person as an engineer. He should have an engineering knowledge, problem analysis, design and development of a solution, conduct investigation of a complex problem, engineering tool usage, engineer in the world, ethics, communication, individual and team, collaborative teamwork, project management and finance, communication, project management, finance, and lifelong learning. 11 attributes have been given by the National Board of Accreditation in alignment with ABET. It is alignment. Similarly, the complex engineering problem has 7 attributes. These attributes, out of 7, WP1 as a mandatory. W2P1 is a mandatory attribute, and WP2 to P7, some or all. Either one with W1, P1 with WP2, then it becomes a complex. WP1 with WP2, P3, P4 complex. WP1 should get attached with any of that 1, 2, 3, 4, 5, 6, 7. Only WP1 is there. 2 to 7, nothing is there. Then its problem is not a complex problem. So the complex problem, it is one from WP1 to WP7. Complex engineering activities EA1 to EA5. At present, it is not our focus because that is the focus of professional competency bill, which is not been passed till today. So today's lecture is going to focus on WP1 to WP7. WP1 is a mandatory criteria, but only if it is present, there is no WP2 to P7, then also it is not complex problem. When it becomes a complex problem, WP1 is available. In addition to WP1, either one from WP2 to P7, either one or more or everything, it makes a complex engineering problem. What are the attributes? Depth of knowledge required. The depth of knowledge required. That is very, very important. How much depth? Because you cannot handle the content with first year subjects alone. It is not at all possible. That is depth of knowledge. Second comes the range of conflicting requirements. Range of conflicting requirements. I will be covering each one by one. Just with the 2 case studies we are going to cover, but not the case studies which I discussed in Adi Shankara. There I discussed Italy and some other case study. I'm not showing that case study here. I'm just taking a simple case study since it's an online program. So first one is a depth of knowledge required. Second one, the range of conflicting requirement. Third one, depth of analysis required. Depth of knowledge also matters. Depth of analysis also matters. Please remember, both matters a lot. Depth of knowledge and depth of analysis. Depth of analysis. And then comes familiarity of the issue. How familiar we are with this issue. That is the next step. And then extent of applicable code. Applicable code. So whether the code is applicable to computer science branch, yes, of course it's applicable. Last time when I came, I have shown some slide to the which I'm not showing to you now. There are some coded provisions which you should remember, which you should be aware when you want to implement something new to the system. That is what very, very important. Extent of applicable code. Then comes range of conflicting requirements. with the extent of stakeholders involvement. The extent of stakeholders involvement and conflicting requirement. Extent of stakeholder involvement and conflicting requirement. Then comes interdependence. Interdependence. These are the 7 attributes. Attribute number 1 is depth of knowledge required, that is mandatory. From WP2, that is the extent of conflict, range of conflicting requirements, depth of analysis required, familiarity of the issue, extent of applicable code, extent of stakeholder involvement and conflict required, interdependence matters a lot. You have to remember, complex engineering problem cannot be solved without advanced engineering fundamental. Beyond first year, very, very important. There should be trade-off between cost, safety, economy, environment, and ethics. That is, economy is cost. So, cost, safety, environment, and ethics. These are the 4 aspects which you have to take into consideration. Then multiple sub-problems that interact non-linearity. Multiple sub-problems that is there, which how you are trying to connect it and making as a single thread, that is matters a lot. No directly applicable standards or codes. Different groups have a different success criteria, limited time, but
Hmm.
Janardhan sir.
Dear participants, there seems to be a network issue at sir's end. Please wait momentarily, he'll join.
profound apology. There was a power shutdown. I am staying in the NIT guest house only. So there was a power shutdown. Maybe because all training halls are there in the same guest house. Very nicely they constructed. Each floor they have some training halls which connected with a good this thing. The same walls opposite to my room is the one more training hall where we are delivering lecture. So that is the reason I resumed. But sudden power cut. Hope now is it audible? I will share the slide once again. Okay. So we started with the this thing. So we have to have a clarity how it could be done. That is very, very important. So no limited time, budget, everything, whatever your faculty members have told, all are correct, and we will see one by one. So we have discussed. So as I told you, the graduate attributes PO and PEO, which results in the complex engineering problem, complex engineering activity, and sustainable development active goals. So now today focus is complex engineering problem. So we have to see what exactly the complex engineering problem. And as I told you, in Washington Accord, we discuss only on complex engineering problem. In Sydney Accord, we focus on broadly defined problem. In Dublin Accord, we focus on well-defined problem. But unfortunately, our engineers who are graduating, they are not even in the position to develop the well-defined problems. They are not in the position to work on even the well-defined problem. That is the problem. So let us focus on what exactly the complex engineering problem. As I told you, three accords are there. We have discussed. Okay. In complex engineering problem, the solution path, it is routine and simple in the case of a routine problem. In a complex engineering problem, not obvious, require synthesis. Require synthesis. That is a very, very important aspect. Information, it is completely and given. Here it is incomplete or sometimes it contradictory. Course correction has to be made, and it depends upon different discipline we are going to work. It is a qualitative also sometimes. Methods, standard formulas will be there. That is the reason students. But here we will be focusing on simulation, some expert judgment, and this because exactly whatever you have been defined in the code, it doesn't need to be followed. You have to look in a different perspective, different aspects. Information and methods, it is single correct answer, single domain, but it is multiple option and multidisciplinary. In general, complex engineering problem, we are trying to focus on a multiple disciplinary approach. Multidisciplinary approach. As I told you during my training program, so the final year project need to be a interdisciplinary aspect, multidisciplinary. A two civil engineering students will should work with the two computer science students, should produce some package, should to develop. The MBA graduates should work with the computer science people in developing data analysis package or something, which gives a more grip for both aspects. The team spirit is going to come, which help us to visualize in a better manner or a different manner. That is the important aspect which you should remember. So what are the problem analysis? You should be in the position to identify the problem, design and development of a solution, investigation, ethics and society, communication and teamwork. So now we are going to discuss about what are the attributes.
So, dear participants, so please have a patience and cooperate. And Sir is presenting his session in NIT Calicut venue. There is another program going on in NIT Calicut by NITTR. Sir is also part of it. So let us understand his conditions and let us cooperate. So please pray, and be patient and be there in the session. Sir is asking us to wait as he is connecting the meeting with his mobile network. So let us wait.
Please note the participant with the display name Riddhima. Kindly mute yourself, please.
Sorry, madam. It was got power goes and come, goes and come, goes and come. But here, even mobile data is not connecting. It is so weak. I was connecting, trying to connect.
That is understandable, sir. And we know that now you are in NIT campus.
Am I audible?
So your connection doesn't seem to be perfect. We could hear you in between, but not very clearly.
Hello?
Yes, sir, you're audible now.
Okay, thank you, ma. So, okay. There is, I don't know what is the reason for frequent power cut here. Yesterday it was good, but I don't know what is the reason. Sorry, profound apology. I don't know. Sometimes it should not give. But any event which starts with hiccups is going to be a good success. That is what told in Ramayana. So hopefully we believe that. Sri Om Se Bhagavad Namni. Any event. Okay. So as I told you before the preamble, during the preamble session, the complex engineering problem should contain 7 attributes: sir. Depth of knowledge, range of conflicting requirements, depth of analysis, familiarity of the issue, extent of applicable code, extent of stakeholders' involvement and conflicting requirements, and interdependence. These are the 7 attributes which you should remember. But when it depends on this, as an individual, I don't know what exactly the depth of analysis. But before looking into it, there are some simple thumb rules which we follow when we go for evaluation. These are the questions whether you have answered. If these are the questions I've taken into consideration, okay, you can give it to the complex engineering problem because now already it has been implemented from 2024. Now we are been visiting various institutions. There, when we ask the complex engineering problem, even the very premier CFTAs, they are not aware about complex engineering terminology, but what contributes this to complex engineering problem, the 7 attributes, they are not aware. So, since they are not aware how to take into consideration, and already the evaluation what we are doing for the colleges, very famous colleges in Mysore, Vijay, various places, they have already completed this work. Asking them to fit into that part may not be easily, it is not advisable. So what we have been doing, we just check these are the attributes which connects. These questions are the answer. If it is answered, then you can connect it to complex engineering problem. That is a one thumb rule which we are operating. But over a years, we expect this part, uh, all the answers to the 7 attributes part. But now, to start with, what are the failures? You can see any failure, famous failures, challenger, or even you take recent failures of the A2 crash. So they are telling it is what the technical problem was there, whether the resources are going wrong or any ethical breach is there, because like Chernobyl disaster, it is basically due to ethical. Bhopal gas tragedy, ethical aspect, or it is a mistake of some individuals. So like that. So some questions you need to focus. Is this problem truly defined? Who are all the stakeholders? What constraints are there? What it is not known? So first framework which we do at present in several colleges when we go for visit, 5W2H method. This method is used to check whether your problem which your students did past 2 years before, 3 years before, is it a complex? What W? What? The physical phenomena. What is a failure mode? Is it a performance gap? What is that? Is it due to performance gap? Or is it some phenomenon problem? Or it is a failure? What has happened in the problem? What was the issue which you have taken up for the problem? Undergraduate problem or a postgraduate problem? Why? Why is root causes? Why this problem has happened? Because in the class when I was teaching, I used to teach with the rat mouse trap. I used to teach generally. So why? Why this has happened? What happened? Why it has happened? Where it has happened? That is also important. In the case of your guys, whether it is in input there was a problem, or is it during the process it was a problem, or output it was a problem. Recently, one scaffolding issue was there with the NSG when we were discussing. So there we have told during the process it was a problem. It is input was correct, output has collapsed because of the process. So where the things have happened, this to define this as a complex thing problem. It is location in the system. It's a problem system. So what, when, why, where, and when. When under specific loading time or operating time or operating conditions. Because when they casted, suddenly a spell of heavy rain was observed. That resulted in some issues which we cannot reveal, but happened. So you have to remember what condition it has happened. This condition is not routine. It is unexpected condition. So this unexpected condition, why it has not been taken into consideration during the design aspect? Why the design aspect has taken this will be implemented only during this month? Whether in the past, whether such things have happened. So these are the questions which we have to ask. What, why, when, and where. In addition to this, one more W I told you who is affected. Is it environment or operator or a public? Because stakeholder, extent of stakeholder and range of stakeholder, range of conflicting requirement, extent of stakeholder and conflicting requirement. Who is affected? How it has deducted and how much it has cost. So these 5 W's and 2 H's, at present we are deploying it just to check whether the problem is really complex or not. If so, then we see interdependence. This is not for this alone, which as a whole, how it is going to get connected. So that is what it is there. Best tool analysis is breaking the system into small functions, then finally putting the whole to part and part to whole. How you are taking into consideration whole to part and part to whole. And cause effect analysis. The fishbone diagram is a fantastic way, even in the NAC or even in strategic planning, we focus on fishbone diagram. How the cost effect analysis, how the interdisciplinary issues, because if this is scaffolding which was taken in a different perspective, the issue which I was discussed, if it would have been other type of a scaffolding, whether this would have solved, this problem would have occurred or not. Because when designing itself, we have to work as if in the forensic aspect. In the forensic aspect, it has to be drawn. And boundary diagram. And analysis is not about simply taking away the complexity, but it is structuring it. How you are going to structure it. That is what it is needed. So what category? Root cause analysis, 5 whys, fault tree analysis, failure mode effect analysis, whatever, whichever way which you are confident, you have to do it. Second comes decision making under uncertainty. So what correlation simulations or sensitive analysis, how you are taking into consideration trade-off, particle optimization, weighted decision making, or multidisciplinary modeling. So co-simulation, Simulink with any CFD is anything which you are taking into consideration. So this is what which you have to take it from the perspective of complex engineering problem. From the perspective of complex engineering problem. So what happened everywhere now the road problem comes. Even recently from Tidal Park, Madhya Payala, NITTT, the Tidal Park side, they constructed a U-type flyover and one more flyover they've constructed. We presumed construction of this flyover will stop the problem bottleneck issue at the junction of Taramani Road, CSIR Road with the Rajiv Gandhi Saleh. Previously, that was a big issue which was there. So they proposed this problem. But what happened after construction opening ceremony? Now this issue has aggravated like anything. Whenever we want to leave the campus at 5:30 at 6, in the traffic jam, we have to stuck more than 30 to 45 minutes. Better instead of standing in the traffic with the vehicle on, so better we can stay in the campus up to 6:45. Then we can go. That is the mindset of few faculty members which has happened. So what is that? Because the stakeholders, conflicting requirement and unknowns, interdependency was there, analysis tool which they have used, which not solved the problem. Because we need, the problem has to be taken into different. So the problem is how the travel time need to be reduced without exceeding the cost, with lowering the transport CO2 emission. Now that is the perspective which you have to work. Because MRTS is their opposite and metro is coming below. So when MRTS is there, metro is not initiated. Before that itself, this much issue, how to tackle this problem. Because this is one of the complex engineering problem, which is multidisciplinary approach. And electronics, because laptop, whenever I use my laptop, sometimes because of heat, it gets into problem. So what is a cooling fan? I purchased a Tata, which has a cooling fan. But if it is a surface temperature is more than 45, if the ambient temperature is different, so how this damage has to be taken into consideration? How we have to work on it? So is it external cooling effect or internal cooling effect? How we have to take into approach? So this has to be dealt with thermomechanical people, electronics people, and computer science people, or people with electronics with thermal management background. So that's because when I came to Adi Shankara, the noise detection, ambient noise, faculty members were explaining very nicely. He was enthusiastically explaining about this problem, how the sound, aeronautics with the noise, how it controlled. He was explaining. So these issues cannot be solved in one dimension. It has to be multi-dimensional. So the takeaway message in the complex engineering problem, first message is, it is predominantly focusing on multidisciplinary approach. If it is simple approach, even in discipline domain, it has to take into the consideration of 5 Ws and 2 Hs. That is the aspect which you have to remember. So what is a pitfall and what is a premature convergence? And solving a sub-problem, thinking that it will solve the whole problem, but because this is a problem of Tidal Park. They thought that U-turn flyover and the subsequent flyover to CSIR Road will avoid the bottleneck at the junction. But this is not taken into consideration because the number of vehicles which are coming this region, becomes more when compared to other region, because the bypassing the Velacheri Road, the people are coming because of the metro construction in the next junction. So which resulted in the bottleneck in the current, which the people, engineers are telling it is a intermediate problem. It will be solved once that junction metro work has been cleared. Hopefully, we don't know. Because don't solve the problem in a sub-problem, but think whole problem and solve it. So whole to part and part to whole need to be taken into consideration. Uncertainty. Obviously, uncertainty will come, which has to be taken into consideration. You should not simplify the constraints and human factors. As I told you what happened during our Nasik visit. So that was a human factor, usability failure. and decision making. So let us look into the complex engineering problem one by one, sir. So first one is the depth of knowledge required. Depth of knowledge, it is knowledge gained from all the courses. So then that all the courses is the professional core courses. It is always appropriate to work on a complex engineering problem because even the first year subjects, whether it will not give, but once they go with the core, fundamental core subjects, then it will be easy. So this gives a necessity from a third year and a fourth year, the people can work on the complex engineering problem because learning activity which are introduced beyond the introductory interaction level. The first year and second year, predominantly the focus is only on the preliminary aspects of the fundamentals. If they are working on the fundamental redefinition, then it is a complex problem. But they are predominantly our engineering application projects are going to be on the application domain. Application domain can be done only after this issue. That is the aspect which you have to take into consideration. That we have to take into consideration. That is one. Second, so first principles directly establish law of chemistry, physics, and mathematics, everything. So meaning is the problem cannot be solved with the surface level knowledge. So in-depth knowledge is needed. So where it covers WK1, WK3, WK4, WK5, WK6 or WK8, which allows the fundamental base principles analytical approach. WK8 predominantly talks about research literature. WK3, 4, 5, 6 are greater than 1 knowledge at the level. So example, suppose if you are designing a suspension bridge using a equations, differential equation, material science about the bed fatigue and creep, and fluid mechanics. We were asking why the wires has to be shrink and it has to be kept. And we were asking the students when we were doing the demonstration workshop, how the compression could be taken into more, how the water, suppose if I'm wetting the water, completely wet the water towel with the water, then how I have to, because if I compress with my hand, the water will squeeze out. But if I want to remove the maximum water, best is only torque. Torque, it is very, very important, which removes all the water from the sink. That is the reason in the suspension springs, why the spring bridge, the cables are kept in that direction. When we teach something, if you teach the reason behind it to the student, it is there. That is the reason the interaction with the faculty members with the industry plays an important role, because industry, for example, recently we were working on one oil industry where they are making a structures for oil structure as a part of our industrial oriented courses, where they explained previously we do stat separately, ETAP separately, estimation separately, AutoCAD separately. But in industry, all our integrated software packages are available. How they customize and they made it, which they are using it in the industry. From an industry perspective, if you do one, automatically the rest of the thing comes, which you no need to work extra. So that integration, how they made it for the commercial, because here we are learning separately how to cut vegetables separately, masala grinding, but how they make holistically, that matters a lot. That matters a lot. So industry. So now this program focus on the concept of what exactly the complex engineering problem. But now you have to connect it with the TCS industry people on connecting to your domain specific knowledge. That is what very, very important of this lecture. So the first one is a depth of knowledge required. I am emphasizing the depth of knowledge required is very simple. We have to remember it should not be focused on surface knowledge of the content. It has to go beyond introductory level, because then comes the third year and fourth year for the second. Range of conflicting requirements, What constraints are placed to resolve this problem? What conflicting demand are there? How the constraints are defined? So those aspects we have to take into consideration. For example, this is a domain which makes a trade-off between science, society, and environment. technology, society, environment, range of conflicting requirement between this thing. So, for example, if you are developing an hydro dam, if you're constructing, engineer must balance on the energy generation, technically, displacement of communities, social aspect, ecological impact on the rivers, environmental aspect. So the range of conflicting requirements. Suppose if you are providing a software solution, the solution should run in a faster manner, in a simpler interaction with the public, with all segment of the public, even the low among less smarter among us should be in the position to use. Optimum energy usage, the storage capacity, the data which you take in. So whenever you develop any work on complex, it is a conflicting requirement within technology, society, and the environment. These multiple span, what trade-off you are going to make it? What trade-off you are going to make it for the software usage? Because every version cannot come in the first. So how the breadth and conflict of interest, not from just a technical perspective. It is not focusing only from the technical perspective. It is focusing from the complete dimension. The complete dimension, it is taken into consideration. Complete dimension, it is taken into consideration. That way, we have to take into consideration, we have to operate it. So that is the important aspect. So the breadth and the conflict of interest. Third, depth of analysis. No obvious solution. No obvious solution. It requires abstract thinking and originality in the analysis and formulate the suitable models. Formulate the suitable models. That is very, very important because the issue is very simple. So how we have to operate? Because it is not only one solution. No only operate. It requires abstract thinking. For example, we have made what are the guidance, constraints, approach to the solution, how the problem was defined, whether the problem had a defined boundaries were there, how it could be done. So I would have given an example. So the standard methods or code does not provide a clear answer. Where you need to work on a new approaches, depth of. For example, creating a biodegradable plastics from algae. Because it's a novel chemical process and innovated for you need a depth of analysis. I told some examples I used to take when we are doing but for that, you need to have a depth of knowledge is needed. Depth of knowledge only will help us to connect with the depth of analysis. Sometimes depth of knowledge, you have a good knowledge, but depth is not there. You cannot do the analysis. For example, I usually, whenever you are doing any testing procedure, any principles, you should know what is the reason behind that procedure. Why 0.45 FCK it has been told by AS456, we are the students. Why can't it find 4.6? Why can't it be 0.3? Whereas in the case of a steel structures, they are taking into different consideration. What is the reason? Since code tells don't follow it, but know the reason before following. Because you're all engineers, we are not a technicians. Technicians has to work on a well-defined problem. What has been told has to be operated. They cannot do difference, but they should know the difference. But as engineers, what is the reason behind it? For example, recently in the park in Madhya Pradesh, they have made a connecting with algae which consumes the CO2, which tries to clean the air in the public domain places they have kept it. So how far it is feasible? So for that, you need to have a depth of analysis. Doesn't mean that all complex engineering problems should find a new solution. No, it is not a new solution. It is a solution which is of innovative solution based on the for existing problem or existing solution. We are doing a value addition to it. That is also a complex engineering problem. So depth of knowledge required, range of conflicting requirement, as I told you, between technology, society, and environment, depth of analysis required. Depth of analysis required. So it focus on creativity and innovation. That's a two terminology in the depth. Already it might be available. We are doing some details because yesterday I was visiting one of the institutions where they have a table. The table is there and the desk is there. The people can write it. Once the table and desk is not needed, so why they are making the desk top portion into bottom and they made it into a chair with this thing. It was a very good innovative design. The people, they did it, creativity and innovation. The same table and chair has been converted into only a row of desk when the situation arises. So when the student comes, they are making it a table and this thing. The space optimization. So it is a creativity and innovation which matters a lot. Then comes familiarity of the issue, which you have not encountered frequently. That is what, for example, I would have told the problem is it's new problem, not previously encountered one aspect. Familiar problem with either clear defined methods are there, but practice used to resolve. Some issues we are going to change it. For example, constructing houses, because you might know how to construct house in the India, Earth. But if you want to make habitat for human settlement at Mars, because Elon Musk has told, he's the first trillion, no, he told the satellite which goes and comes back, which he is also invented. In that situation, how we have to operate it, how we have to operate it, how we have to make it. That is very, very important. So that is it. So he might work on the human settlement, but human settlement on the Mars, how it could be done, that is very, very important. It is rare and novelty. It's rare and novelty. It is unlike routine engineering problem, which we have not encountered regularly. So it is a unique problem which you are going to face it. Then extent of applicable code, standard code which are available, but how the standard code has to be reformed or rephrased. That is very, very important. So already code might be available. This code might have not taken this into consideration. There are some instances when we went with NSG, they have told how their work resulted in the modification or value addition in the code and provision, because codal provision is continuously which we are evolving, which we are making into periodically into consideration. So how we have to make it, so how to do the analysis, how to make the things further, so applying engineering skills to address some parts of the problem that were not clearly prescribed by the standards, codes, or practices. So how to develop your own criteria, because which you are going to make it. So as a computer science engineers, we have told last time when we went to Shenzhen University near China, and during the 2018 and 19 for a program of UNESCO, where we have seen how the security subjects were being taught with ISO codes. So especially the computer science codes only I have taken note down and again. So what are the ISO codes they are using it? So for software testing, software application, everything. As an individual, we are not aware what exactly required in the security aspect. So what it has to be covered and what are the, for example, offshore wind in a deep waters, how it has to apply, how the turbine has to be structured, because we may not be, current code may not be focusing on deep water, because it might the water, this condition, environment condition, their longevity, everything need to be taken into consideration. So those aspects need to be focused on the fifth criteria, extent of applicability. So the attributes points to the regulatory gaps or value addition. So the fifth attribute is regulatory gaps and identifying it. Sixth aspect is extent of stakeholder involvement and conflicting requirement. Extent of stakeholder involvement and conflicting requirement is very, very important, where you involve diverse groups with a varying requirement. So, for example, what are the interests of each stakeholders on the problem, or anything conflicting is there? Who are all the stakeholders? What are the interests or requirements? Extent of these interests, requirement conflicted, and placed constraints on the problem. How do you manage these stakeholders, resolve conflicts, and meet the requirements and reach satisfactory compromise? That is very, very important. Very, very important and very, very need of the hour. So the diverse groups of stakeholders, widely varying needs, how it has to be taken into consideration, how do the stakeholders' interests matters, and what are the aspects. So with example, I would have told them, government, industry, community, environment, each group will have their own requirement. For example, urban metro rail project has been constructed. Commuter wants affordability. It has to be economically cheaper. Government wants efficiency, hopefully. Business wants minimal disruption and the construction need to be implemented at faster rate and the returns has to come in a group. And environmentalists want sustainability. It should not deroute. Several metros have been constructed. Now, there are some issues whether any aquifer which is constructed. Each way they are discussing from environmental aspects. So, any projects, how the different group of stakeholders under conflicting. There in the criteria number 2 of extent of conflicting requirement, we discussed about technology, economy, and the society. Here, the society is also there, technology is also there, but in the stakeholders, different stakeholders' perspective we are taking into consideration. From a commuter perspective, what is required? Government perspective, what is required? Business perspective, what it is required? Environment perspective, what it is, the sustainability. Because then the projects, if you handle such issues, you are working on a complex problem because you want to take into different situation. Making a small tiffin is very important, but making a side dish becomes a complex for any family members. Your son might like one, your father might like one, you will like one, your wife might like one. How to tackle the things in a better manner, that is very, very important. So the difference attributes not just technical problem solving, it focus on stakeholder management and negotiation. Very, very important. How you negotiate technically, how you negotiate without compromising on the end requirement. That is very, very important. Then focus on interdependence. Interdependence. How we have to work on interconnected sub-problems, not physically, but mathematically. So how to do it? Smart city design involves transportation, energy, waste management, water supply, ICT system, all integrated. But we have to remember, each attributes focus on different complexity and integration. But isolated task we might have worked. In transportation, we might have worked in a different direction. Energy, we might have worked in a different direction. Waste management. But when you put together everything in one bundle, how it operates, how it focuses, that is what we call it as a interdependence. It is not a small component. It is not a high level of making all components together and a sub-problem together. So the complex engineering problem, in-depth knowledge, that is the first attribute which I have told. In-depth knowledge, the depth of knowledge required. It is a technical depth. So baseline requirement of complex engineering problem. Second, wide range of conflicting requirement. Conflicting requirement. Here the focus is breadth across the domain, breadth across society, technology, and environment. Breadth across the domain. That is what. So trade-off between technology, society, and environment. Third comes the depth of no obvious solution. That is a third depth of creativity and innovation. How the creativity and innovation plays an important role. That is the depth of analysis required. Then comes the novel or infrequent familiarity issue. Rarity, the problems are not encountered, commonly encountered. As I told you, construction of a Mars planet in the Mars. That is what. So outside codal, because regulatory gap beyond existing standard, diverse stakeholders, so social dimension, competing priorities to balance, high level multi-component system integration and level large interconnected sub problem. So these 7 aspects, if you take appropriately into your domain, the problem could be solved in a simpler manner. Sir. Problem could be solved in a very, very simpler manner. That is what we call it as a complex engineering problem. Complex engineering problem. It is not from the one perspective. It is a problem from the different perspective. It is problem from the different perspective that we have to take into consideration. So that is what very, very important. That's what we have to focus. If this is taken into consideration appropriately, So there will not be any problem. There will not be any problem. There will not be any issue will not be there, because we are not focusing on the because this problem, when it comes interdisciplinary, these are the challenges. As I told you, it rarity is the issue. But when you work in the interdisciplinary aspect, these challenges attributes could be taken into consideration very easily. So it is not the, because we always look the problem from a simpler dimension, but it is a complex. But students are completed focused. Sir, we are not worried about it complex or simple. We are worried about this project should complete 12 credits are there in an undergraduate project. We should get a good credit. That is what. But faculty works in a different. This project should lead to some good publication in ACA, Q1 or Q2 journal. So each one is working, and management is thinking this problem should fetch them a complex engineering program and should get them a 25 mark in their NBA accreditation. And NBA evaluators really wonder what is happening in the system. 5H and 5Ws and 2Hs. That is a concept. So each different stakeholders see the final year projects from a different perspective. Students from the job market perspective, faculty from a publication perspective, management focus on NBA accreditation perspective. But ultimately, it should solve for the societal problem. That is what it is. So last time I was giving example of Italy to the members of the Adi Shankara, which I am not covering today. So a complex engineering problem is defined only based on the 7 attributes. If the 7 attributes, if it's well clear to you, you can define very easily. Depth of knowledge required, range of conflicting requirement, depth of analysis required, familiarity of the issue, extent of applicable code, extent of stakeholder involvement and conflicting requirement, and interdependence. If this is taken into consideration, then the problem could be defined as a complex or not. That is very, very important. So to define it as a complex, these 7 attributes plays an important role. Out of 7 attributes, the first attribute is a very, very important attribute, that is depth of knowledge required. Depth of knowledge alone will not define a problem as a complex. Depth of knowledge sometimes define a simple engineering problem also. But with a depth of knowledge coupled with any one of the attribute, then the problem could be defined as a complex engineering problem. Depth of knowledge required, extent of stakeholder, range of conflicting requirement, depth of analysis, familiarity of the issue, extent of applicable code, extent of stakeholder involvement, and range of conflicting requirement, and interdependence. This 7 defines the problem as a complex or simple. And in depth of knowledge, you have to W3 to W4, W5, W6, and W8 is the range of literature. So this is what the focus of today's morning session. I know there was quite often there were power fluctuation were there. I extend my profound apology, because we have a other session. My session starts at 1:15 at here. So that is the reason. So if you have any doubts, any question, I request you to, because last time I was teaching them with the 2 case studies, with the normal food case study, but here I'm not teaching those case studies. I'm just focused only on the definition of complex engineering problem and how it has to be taken. As I told you, the problems are simple or complex, but it depends upon the issue. That is the only item, because real world problems are not textbook oriented. It is a multi-dimension, multi-facility. So when your time is given, you have to work on more dissecting the problem, identifying the problem, and providing it to smaller pieces. So it is whole to piece and piece to whole to part, and part to whole. That is the loop cycle which you adopt for the solving the complex engineering problem. If you have any questions, any doubt, I request the participants, feel free to ask. And feel free to ask. That will give more clarity to user, because the content what we delivered in online, because due to the disruption of power, it was different. But as a complex engineering problem, 7 attributes are there. These 7 attributes you should work. Before starting the 7 attributes, the 7 attributes have been declared into a 5W and 2H. What are the 5Ws? What is the problem which you should remember? It is not the question of what is the problem. It is there why it has happened that you have to remember what and why. It is not the where and when. It is the important who and how much you are going to focus. So what is the phenomena, why the root cause analysis, whether the problem has occurred during the input or process or output, and when it occurred, what condition it occurred, who is responsible for it, who is affected, and how it is deducted to solve the problem. Not it is how it's affected to the problem, it is how it's deducted and how much it is going to create this thing. That is what we focus on, a complex engineering problem. If you have any questions or any doubt, I request the participants to question. Over to the participants, please.
Dear participants, if you have any doubts, the session is open to questions. You can kindly put your questions to Sir.
Sir, some questions are written in the chat window.
Okay, I didn't see my. I will look into it once again. I'm looking at questions. Chat window. Okay. How to explore students with the complex. How to explore the students with the complex. Okay, how to expose the students with the complex. Okay, as I told you, if you talk about all the 7 attributes, the students will get confused. First, to the students, you tell them of 5Y, 5W, and yes, I got the question, Vijayalakshmi madam. How to expose. Now, because when we ask any colleges, very, very famous colleges, last month and previous month, I went for an accreditation. When we ask them complex engineering problem attributes, they are not aware. They have submitted the SAR and they with new format we are going, but they are not aware. So then we came up with that. You just check any problem with the student is working. Are they in the position to answer 5W and 2Hs? What, why, when, where, how, who, and how much? That is the questions which they have to answer. Let them prepare. If it is they are in the position to answer all these 7, then they are operating on the complex engineering problem. That's the only way which the students could be exposed. Because if you talk about the depth of analysis, interdependence, and everything, some students might get involved, some students might get confused, and the final real projects itself become a complex and they may not graduate. We should not put them in a trouble. But they should be aware, the depth of knowledge, depth of analysis, everything they should be aware. But to expose them in a very lighter manner, ask them to answer 5W or 2H in their problem statement nowadays. And the students are very clever, because recently we asked some research problem from team. Everyone is putting AI and bringing wonderful question with all methodology, everything. So we are not in the position to assess whether the students has really made it or they asked AI tool to provide a 5W and H. But let them get it, not a big issue. But they should, when they submit, they should have a clarity in answering it. As a teacher, we should be critical in questioning them. Only critical way of questioning them will try to embrace AI with logical content. Otherwise, they embrace AI simply without any logic in it. That is the reason. So expose comes with 5W and 2H. That's the only answer. Vijayalakshmi madam. Okay. Any other question?
Sir.
Yes, ma. Yes,
Sir,
yes.
Vijayalakshmi here again. Can the good curriculum help them to solve in the future complex engineering problems? Good curriculum.
Fantastic. So the students are not, you told the depth of knowledge required, depth of analysis required, but students are not exposed to the depth of knowledge. The curriculum matters. Curriculum only encompass project into it. So one observation, if you observe, now the government is very clear. They are not worried only in delivering the content. They are more focusing on how the content need to be delivered in terms of case studies and real-time examples. Now, the credit is not given based on the teaching, credit is given based on the learning. As during my session at Adishankara, I have exposed, we are giving some worksheet activity. You give them more activity on any issue, connect them with the problem. You, as a faculty members, now the faculty members interaction with the industry, it is also having a point in the NBA accreditation. Why such points has to be given? First, I need to interact with the industry and then comes. For example, when when Kamal Haasan was acting in one of the movie, he interacted with the Kathak dances because dances they discuss. But he observed what sort of things they will be working on it. Then they came with the script. As a faculty members, that is the reason they have given industry interaction, industry internship for the faculty members. You go with the problem, what the content you teach. You go with the same content, identify industry, how this content is being translated into reality. That you identified. Based on your identification, then you can narrow down or you can work on it. That is the beauty. That is the beauty which you have to work. That is the beauty which you have to work on. So in that situation, how we have to operate, that matters a lot. That matters a lot. That gives a more clarity to it. So the teaching learning process in the curriculum should focus on self-learning hours with case studies. Use cases has to be there. Use cases. Ask them with the Python or whenever any program you teach, you interact with the industry people and identify the use cases and give these use cases to them, not to text the memory, to check their understanding. When you check the understanding, depth of knowledge required is coming by depth of analysis is also coming. By default, when they venture into the project, obviously they work on a complex thing. So use cases, practical case studies becomes a must. It becomes a must. Is it clear, sir?
Yes, sir. Yes, sir.
Do we have any more questions from the participants' end? Thank you, sir, for the highly informative session that you delivered. Your detailed explanation of the complex engineering problems and the NBA GAP CV 4.0 framework has provided valuable insights for all the participants who attended the session today. On behalf of Adi Shankara College and the Department of Computer Science and Engineering, we express a sincere gratitude to you, sir. Thank you very much, sir.
Thank you.
Thank you, Jonathan, sir.
Thank you, ma. Thank you, ma.
And sir, sorry,
Tell me what for?
sir. Sorry for troubling you, but your session is actually set a tone for this FEP. Thank you so much, sir.
No problem. It's not at all trouble because we committed, we will do it. But suddenly I didn't expect the power cut, and even when I put data, the data is keep roaming, but it is not coming fast. I don't know what is the reason. The dark environment, maybe I don't know what is the climate here. Thank you, ma. Thanks for the thank you.
So now practically okay, sir. Thank you so much.
Yes, 5W and 2H now only we are seeing, because otherwise the people are not getting concepts. That's the only thing.
Yes.
Thank you, ma. Thank you.
And we know that now when you take offline session, how vibrant it would be. So the online also will be curtailing your energy level. That we understand. And no, so you can ask the participants, express themselves during the session, sir.
Yes,
We'll
no,
be doing.
based on the facial expression, we can ask them questions. Here, everyone
Yes.
camera is on, everything is different. No, you remember, like we are speaking to the wall and a mirror, like that it becomes sometimes.
Yes, sir. I'll understand. Yes, sir.
Thank
And
you.
network is an issue everywhere.
Yes, that is also a problem.
And no, it's a rainy season here in Kerala. So that is
Same,
also
that's
one
the
of the
reason
reasons.
here is. Yes,
Yes,
rainy
yes,
season.
yes. Okay, thank you so much, sir. So please take some food and rest. Tomorrow let us meet.
Madam,
Okay.
will you share the PPTs?
Yes, ma'am, I will give it to madam. I will send it to madam.
Yes, sir. Thank you. Thank you so much, sir.
Dear participants, kindly note that the feedback link has been shared. You're requested to kindly complete the feedback because the attendance will be marked based on the feedback that you provide. So kindly complete the feedback. Thank you very much, and we'll meet you tomorrow for the next session.